Okay, so the first derivative rule that you learned was called the power rule. And the power rule said if you started with a function, for example, a times x to the n, its derivative would be a times n times x to the n minus 1. So the exponent came down in front, and the power was decreased by 1. So if we look at these examples, by the way, n could be a positive value, a negative value, an integer, or a real number. So I have these 4 examples here. A positive integer, so n is 3. Its derivative, if we're looking at f of x is 4/3 x to the third, our derivative would be 3 times 4/3 times x to the second power. We've reduced the power by 1. We've brought that exponent out in front as a coefficient, simplifying 4x squared. Okay, we could use a negative exponent, so the derivative of f of x equals negative 2x to the negative 3 would be negative 3 times negative 2 x to the, reduce the power by 1, negative 4. So that would be 6x to the negative 4. The third one, we have a positive real number, our real number being 1/3. We're going to bring that exponent out in front, 1/3 times 5x, reduce the power by 1, 1/3 minus 3/3, negative 2/3. We'd like to use positive exponents in our answer, so we'll call this 5/3x to the 2/3. It could also be written as the cube root of x squared in the denominator there. Okay, last one, f of x is 7 times x to the negative 1.1. We bring that exponent down in front, that's a negative 7.7. Reduce that power by 1, so it's negative 2.1. Negative 7.7, x to the negative 2.1. Okay, so just a little review of our power rule. All right, we do have lots of examples to look at. Y equals 0 has no value of x, so dy dx is equal to 0. Number 2, pi is a constant. The slope of a constant is 0. Number 3, e is a constant. The derivative of a constant is 0. Number 4, the exponent is 1. We bring that down in front. Reduce the power by 1. Oh, 1x to the 0, or just 1. Remember, this is just a linear function. What is its slope? Its coefficient 1. dy dx equals 2. Y equals 2x. So the derivative is 2. Number 6. Coefficient is 1. Bring that down in front. That's 2/3 times 1, or 2/3. Reduce the power by 1, x to the 0. So no variable term. So the derivative of a constant is 0. The derivative of a linear function is the slope of the linear function. The derivative of a quadratic, bring that coefficient down, or exponent down in front as the coefficient, reduce the power by 1. The derivative of x squared is a linear 2x. Y equals 3x squared. Bring the power down in front. 2 times 3 is 6. Reduce the power by 1. 6x to the first. Again, quadratic function has a linear derivative. Okay, 2x to the 1/4. dy dx is 1/4 times 2 times x to the 1/4 minus 1, 1/4 minus 4/4, negative 3/4. Writing this with positive exponents only, we would get 1/2x to the 3/4. All right, the square root of x is the same as x to the 1/2. dy dx would be 1/2 x to the negative 1/2. Writing that with positive exponents, that's 1/2 the square root of x. Number 11, y is equal to 1/x squared is the same as y is equal to x to the negative 2. Derivative, therefore, dy dx would be negative 2 x to the negative 3. Writing that with positive exponents, negative 2/x cubed. All right, number 12, y is equal to x to the pi. Okay, that's like x to the 3rd. Coefficient is now pi. X to the, reduce the power by 1, pi minus 1. Okay, a few more examples. Y equals x to the e. The derivative is e, x to the e minus 1. Number 14, y equals pi to the e. Pi to the e is a constant. So its derivative is 0. All right. If we have the sum of 3 different functions, like x cubed, negative 3x, and 2, we just take the derivative of each piece. So the derivative of x cubed is 3x squared. The derivative of negative 3x is negative 3. The derivative of 2 is 0. Okay, before you start taking the derivative, sometimes it is helpful if you rewrite the function so that if you have any fractions to begin with, you write them as negative exponents, using negative exponents, and then take the derivative. Be careful not to take the derivative of one part and then rewrite another part. Be talking about the function, talking about the derivative. Be clear about what you're talking about. So first piece, 4t squared has a derivative of 8t. Negative 5t to the negative 1/2 will have a derivative of positive 5/2 t to the negative 3/2. T to the negative 3 will have a derivative of negative 3 t to the negative 4. Once you've taken the derivative of every piece, then it would be wise to rewrite it with positive exponents. So 8t plus 5/2 t to the 3/2 minus 3/t to the 4th. I would say get a common denominator, but I'm going to forego that on this one. Later on, when we're working with derivatives and we want to find out where the derivative is equal to 0 or where it's undefined, getting a common denominator would be a wise move. So we'll practice that a little bit later. Okay, last 2 examples. So sometimes you're given a function that has lots of different letters in it, and you need to know which is the variable we are taking the derivative with respect to. So this is why the notation dy dx is very helpful. It says we're taking the derivative of y with respect to x. With respect to x. So x is our variable. So when we look at this function, y equals x cubed over a plus bx squared minus cx, a, b, and c are viewed as constants. I don't know their values, but they are constant. Okay, so what's the derivative of x cubed over a? Well, first of all, remember that's the same as just 1/a times x cubed. Okay, so we're going to take the derivative of x cubed, which is 3x squared, multiply it by 1/a. 3 over a x squared. The derivative of bx squared. The coefficient b gets to hang out there in front. We will bring down the 2 as the coefficient, reduce the power by 1. The derivative of a linear function, cx, negative cx, will be negative c. All right. Just clean that up a little bit. Okay, let's do number 18. So here we have the derivative of w with respect to q. So our equation is solved for w. Q is the variable in question. What does that mean about a and b? These values are constants. So 3ab squared is just like a coefficient. All right, what's the derivative of w with respect to q? Coefficients get to hang out in front. What's the derivative of q to the third power? It's 3q squared. Excuse me. Simplifying, we get 9ab squared q squared as the derivative of w with respect to q. Okay, I'm going to stop there. That was kind of a wrap-up of the power rule.